Ladies and gentlemen, please take your seats. The show is about to begin. As a courtesy to our speakers, please silence all devices. Ladies and gentlemen, please take your seats. The show is about to begin. As a courtesy to our speakers, please silence all devices. Ladies and gentlemen, please welcome Guido Appenzeller, CTSO of Networking and Security for VMware.
Good morning, everyone. Very excited to be here today. We got a great panel with some of the people that run the largest networks or operate the largest network, provide software for the largest networks in the world. You know, for me personally, I always enjoy seeing what happens in the hyperscale in terms of networking. And the reason is that in many ways, their network designs tend to be ahead of what then gets replicated across the enterprise and other parts of the industry. So without further ado, let me welcome our great panelists. We have David Maltz from Microsoft, Hassam Ahmed from Affirmed Networks, Kitty Pang from Alibaba, and Omar Baldonado from Facebook. And with that, we're open for questions, if there are questions. We've got 2 microphones. Probably know the drill at this point. So if there's no immediate questions, then let me kick this off while people think of them. So looking at the 4 talks here and comparing them, you know, there's a couple of common themes, right? Disaggregation, some overlays, you know, some hardware with your own software on it. If each of you have to gaze into the crystal ball and tell me, how does open network architecture look like 2 years down the road, 3 years down the road? maybe even further? What would you see?
I think that starts with the vision that Omar laid out, which is that there will be open hardware with the key intellectual property and the key features all being implemented in software, because that's what's going to enable us to evolve very quickly and react to changes in the environment and the ability to deploy new features. If anything, I think we will see the hardware itself become more fungible with the ability to even then deploy new offloads and capabilities in that hardware, which can then be leveraged by the software.
So less fixed pipelines?
That's right.
Yeah. Is that the same in mobile?
I think from a mobile perspective, probably the biggest change we're going to see as these technologies get into the infrastructure is service automation. Mm-hmm. At the end of the day, I think you'll be able to see in 2 years the ability of all these capabilities or these platforms to come together and to be able to sit at an interface and just drag and drop service creation.
But this will all happen in software?
Yes.
What is the hardware underneath going to look like?
I think the hardware underneath is going to be probably in 2 years, probably still a combination of off-the-shelf servers like HP's, C7000, and I think you're going to start to see increasingly, open hardware switches with these SDN controllers integrated into the service automation platforms.
So Kitty, how will this look in China?
So, in our opinion, we just want to run faster. So whatever hardware or software, open or closed, and we just choose the low cost and the high efficiencies and the fit-as solutions.
Any way to top what you currently have in terms of openness, Omar?
Oh no, I think there's a lot, and it's an analogy that's been used before, but I would refer to the server world. And if you look at the vibrant hardware and software ecosystem in the server world, right, where you've got a number of companies competing at all the different and providing solutions at all the different layers, I think we'll see that ONF and the SDN movement started that a number of years ago, and we'll continue to see that, especially as we get into open source implementations and code sharing and design sharing. The one other piece I'll point out there is that I think I covered this a little bit yesterday, is that our organizations will change, right? As the networking industry becomes more software oriented, a traditional networking group may have been comprised all of network engineers 5 years ago.
Yeah.
5 years from now, it will be some combination of network engineers, DevOps, and software engineers, which I think a number of us are already seeing, but then I think that will pervade through the whole industry.
Yeah, no, that makes a lot of sense. I think there's this big organizational change ahead for the classical networking team. All right, please.
Thank you. So my question is very simple to Omar. You? Okay. So you mentioned about you have done just 1%. So the rest of 99%, which is the first one would come? Tell me the idea.
So yeah, what's the first step there? I think the one that we're really focused on, right? There are a few steps within the hardware, I think I mentioned, but really this open source ecosystem where we want full solutions, full open source solutions, a better basis for others to come and contribute on top of an open source movement, I think is our first focus. There's quite a barrier right now, and we know it, right? Which is for anyone who wants to come in and adopt some of these open technologies, you have to have developers on your team. You have to do a lot of grotty platform work. I was just talking with Dave about this during the break. There's a lot of work to make these open source pieces work together and integration work. We've got to take away that friction and make it easier for folks to come in and start contributing.
Perfect.
Thank you.
Over here to the right.
Hi, great panel discussion. First, I have two parts to the question. First is for Mr. Ahmed. I think one of the frustrations we have been facing, and you addressed it in slide 12, is that the traditional vendors have this perception that a virtualized workload, the total efficiency that you get is nowhere near what you can do with the closed solutions. But hiding behind it is what you said is about how do you do dynamic insertion, how the whole workflow. So if you could elaborate that, because we have been seeing that vendors have been stalling by just packaging whatever they had on their proprietary in a virtual machine form factor. And the part B question is for Mr. Omar, Mr. Baldonado, I think from Facebook, is we have been seeing that the silicon vendors on even the commodity silicon, they have not been willing to provide their APIs directly as a Linux kernel module, loadable kernel module. Broadcom provides it in the user space. It's not looking like a server where if I have a special graphics processor, it's just a separate component. I should be able to program it with a driver. And that would make it a lot easier for people who have been trying to program on top, instead of doing backhooks and trying to come up with a cumulus kind of model. So is there some way you guys who are like the big 7 content providers can force this into the loadable kernel module?
Okay, well, with part A of your question, if you were a fly on the wall, perhaps inside some of these incumbents, I think the discussion would go something like this: how do we delay this stuff? And I think you're insightful in realizing that by kind of paying lip service, or maybe a little bit of actual service to the space, by encapsulating existing applications in VMs, you can kind of show a direction, but then just keep doing what you're doing. And that is exactly sort of the worry. And I think this, by the way, to Guru's point earlier, I think this is the reason you want to have startups in this world, is because the object of the game is to create fear, right? Oh yeah, this stuff isn't quite ready. We'll get there too. Just keep doing what you're doing. And the reality is that whenever there's a discontinuity in a market like this, you really have to approach the problem from a new vantage point. And when you do that, you're able to really not only do what the legacy technology did, but really outperform it. And I think that's sort of the key learning in what we do. And a big part of this really has to do, it really has very little to do with the hardware. Everybody hides behind the hardware. It has nothing to do with the hardware, quite honestly. It has everything to do with the software. The capability of chips that run in one of these legacy platforms, the capability of x86 today is not dramatically different. The real problem is that the software architectures that were put into place in the mobile space 15 years ago when data first started, didn't anticipate the richness of data. It was mostly about email and checking and WAP browsers back in the day. And the reality is that in our industry, what happens is that you build the software once and then you kind of progress it to newer and newer hardware platforms. And the problem is that the software is just not well matched to what you want to do with multi-kernel processors in today's hardware environment. So when you start with a clean sheet of paper, you're able to deliver the level of performance and do a lot of the processing and the fast path to do it. That was a big part of how the realization that we had and how to make this happen.
Right, that was a 2-for-1. So actually, I would defer to Dave, actually, because Dave actually leads, and his team leads the switch abstraction interface effort within the OCP. And so if you don't mind me punting over to if you want to take that one.
Surely. Yeah, the entire goal of the switch abstraction interface was to make it easy to essentially develop management services that run the network, and then be able to take that software after we've invested in debugging it and making it work, port it easily across technology platforms. The networking industry is developing at a tremendous rate. Every 18 months or more, there are entirely new chip technologies and link technologies coming out. And we want to be able to take that infrastructure that we've built and battle tested and move it with the technologies it advances. And so the idea of the switch abstraction interface was to put a common layer between the hardware and all of that software. So as the software is written, it can continue to then replat across the different platforms.
Oh, to the left here.
So as you are all industrializing these technologies and the workloads become more complex and business critical for your users, What do you see as the outstanding security and reliability issues? Are there any? Are they solved, or is there still work to be done?
All of them solved?
Who's going to take? Were you asking me first, or
Go for it.
1% finished? Let's see. So, I think there's a lot of work, and it relates to, I think, what everyone, Kitty, you said this too, and definitely, actually, we all said it in terms of reliability. A lot of it starts with the monitoring, and I think getting better sense of just how well all of this is doing is an underappreciated or often overlooked piece of the SDN software world that I think vendors and operators, we can work more together on that. Security is actually a big open one too. I was just talking to somebody about, is it less secure? It was interesting. Is it less secure to have your open source hardware designs open like this? Is it less secure to have your FBOSS software out there in the open? I think actually, it's again somewhat trite there to say, but I think the open source and collaboration will help some of that. But we're not at all done there.
So actually, if I can slightly expand on that question. So in general, not only for the open versus closed hardware or source part, would you think that an SDN-based system is more secure or less secure than sort of a classical distributed networking hardware?
I would say that it's actually more secure. And the reason is that security is often a question of usability, which is that I think we have implemented a base level of security which is sufficient and keeps people's data secure. The question is making it sufficiently usable so that both our tenants and the operators of the infrastructure don't accidentally or inadvertently try and subvert that security in order to get their jobs done. That's been the tension we've seen. As I referred to, being able to roll over certs easily, which SDN makes easier, actually helps you get better security.
Yeah.
When you don't have that level of automation, there's a tendency to say, okay, no, we're not going to roll that password because that would be too hard. But as we move more into the software, we create the automation and orchestration systems to support it, security actually gets better. I would say similarly, again, echoing what Omar was saying, around availability, the fact that we are now extracting more of the logic and put in the software actually makes it easier to build a highly available system. Some of the hardest problems I have to debug are actually gray failures that occur in the hardware or occur in the interaction between software and hardware. But as we put more agents out into the network in more places, we get more monitoring points, more visibility that allow us to triangulate and find these gray failures, these intermittent issues, and then actually get them fixed and get them out of the network. So my belief is that availability is actually going up as we're adding more flexibility and programmability.
So is there, I want to actually stay on this topic because I think it's really interesting. Is there I read a statistic that if you look at the large data breaches last year, right? Last year was terrible from a security point of view, that for the majority of breaches, the reason was misconfiguration. So is there an argument that actually the higher degree of automation helps on that side as well?
Absolutely. Once you have more configuration, you have your policies expressed in machine-readable format. Inside Microsoft, we have significant types of actually basically resolution theorem provers that are continuously checking the configurations we have on our devices against the stated policies that will automatically detect discrepancies and then take action to resolve them. When you have a conventional network, it's just much harder to do that.
Hard, yeah.
I can tell you on the mobile side, I don't think the job's ever done, unfortunately, because people are always creating new ways of attacking your network. So a big part of our focus and our security architecture has been around protecting the network and protecting mobile-to-mobile kind of attacks. We don't purport, however, to believe that we do everything that has to happen inside a POP or a data center, and indeed there's multiple layers of security that we rely on in an operator's implementation. To kind of echo a little bit what David was saying, we do a bunch of service consistency checking exactly for the same reason, which is making sure that there aren't misconfigurations that open up holes.
Security?
I think the security issues is a bigger challenge for the cloud networking providers. So actually, I agree with the security is another question solve the piece to the need to the how to say, so need to the industry to focus it to solve these problems. So.
Super.
Totally, misconfiguration is a huge part of the issue, and so anything you can do to make it simpler and automated is huge. Also, from an attack surface, like one of the reasons that we did some of our own implementations is that we don't need a lot of other protocols, we don't need a lot of other things in there, right? So, like you said, I think your data center, a lot of your underlay is just BGP, and your underlay is pretty simple that way, and so your switches may not need a lot of this other software. Same thing for us. We don't run spanning tree, we don't run any number of other routing protocols, we just have BGP and that's it. And from that perspective, it becomes easier. We roll certs, we roll software patches weekly, daily. Helps that way.
Super. All right, next question.
Hi. My question kind of takes us back to the organizational and cultural things, like Omar kind of touched on it already. Could you guys elaborate or maybe give some specific examples of that journey each of your teams had to take from the people skill set, the organizational culture, in order to make the progress? Because, I see a lot of great technology coming, and with forums and people like everyone here, it's going to keep going. But getting it into the organization, getting it working, is going to take a skill set of people and organizational change. And I keep hearing it. I heard the theme this morning. I've heard it from other sources that, well, we're going to look very different or we're going to have different skill sets. But I'd like to hear something very specific, maybe from each of you, about what was the key thing you got from the people and organizational challenge of this. Thank you.
So how do we get rid of silos? Who wants to start? Omar?
Culture.
So I covered this briefly yesterday in one of the tutorials, but it's definitely an evolution. Like all of a sudden you don't just you change your engineering group from this mix to this mix, right? And also I think you have to choose the domains, right? And so we thought of it the way networking software got rolled out through Facebook. Largely, let's say several years ago, it was a lot of network engineers putting stuff together from vendors. But then we started introducing more and more software in the debugging and troubleshooting and monitoring areas. We started there first. And then we started looking at automation and provisioning of configuration, sort of policies and intent. And then we started looking at these control systems, right? So the same engineers who started off by looking at how can we do better software monitoring and alarming and alerting, they then were getting their feet wet and getting experiences. Then we said, now let's try to create a policy database for configuration. And then once we got kind of a handle of that, then we felt ready to go, let's now do this control stuff, like centralized control, programming switches and all that. So we definitely did not jump all the way into the deep end of let's start programming switches directly. We started there at the monitoring side.
I would say our journey at Microsoft started with human relationships, actually building up trust. In many organizations, there's distrust between the classic network engineering organization and the server operations or the software engineering discipline.
We've all seen that, yeah.
And it started with us, basically the leaders of the network engineers and myself as the leader of the software, basically agreeing that we would never point fingers at each other whenever anything bad happened. And from that, we were then able to start making progress on the technology. In terms of skill set, we've been essentially embedding network engineers together with software engineers so that the network engineers can help provide network clue to the software engineers, and the software engineers can help the network engineers design and architect good systems and actually come up with network architectures that'll be amenable and friendly to software automation. And that holistic design has actually been one of the key enabling insights that we've had that has let us make forward progress quickly.
So Hassan, you're dealing more with carriers. Have you ever seen situations where you have a hostile networking team that actually feels threatened by this change?
Yeah, actually, the social issue is very, very interesting because what happens is when you introduce service automation, you change the operations model. And the CTO thinks this is fantastic. It's going to give them all these advantages and speed and all that. The networking team is scared because they say, wait a minute, this is my job we're talking about. And so it creates this really asymmetric social issue. And then add to that the fact that changing the network and changing the operations inside most operators is sometimes just a bridge too far to do in one step. So what we've done to address that is a big part of it is building the trust that David was talking about. But then in our what we've also done is created an operations model where effectively you can run the new network using the old operations structure until you're ready to kind of adopt the new service automation structure. And that's helped a lot in being able to move these networks forward quickly, just because people, particularly the operations guys, are doing things that they're already quite accustomed to. There's a huge retraining issue, though, I can tell you, that operators have to undertake. We heard Andre talk about that this morning. They've probably been on the leading edge of getting their workforce retrained. Others haven't.
How's that for you, Kitty? Is it more organization or more technology? What's the bigger problem?
In past few years, the developer operations and the networks engineers is a separate, different the positions. So last year we think about maybe the DevOps is a new positions, and currently we want to find some talented guys to we call it the full stack engineer.
Yeah, that makes sense. Super. Please.
Hey, thanks for hosting the panel. This is very interesting. Dave, you talked about QoS, and specifically flow-based QoS is an important concern, inside any network. Can you give a specific example or maybe elaborate on how you achieve flow-based QoS using SDN or, maybe if it spans L2, L3?
Okay, a great question. So first, we are entirely an L3 network. So the L2, layer 2 primitives that are seen by our tenants are created by the NFV and the SDN. We've had to use a multifaceted strategy. It seems like no one solution will work. We use diffserv extensively. We have multiple classes defined on our network in multiple queues. And that's because we're handling multiple different types of traffic, some that are very latency sensitive, some that are latency insensitive. We use RDMA extensively. So we also have priority flow control running, not in sort of the traditional data center bridging model, but essentially hop by hop, we've taken that concept and injected it into layer 3. And so the physical network is prepared to receive these different classes of traffic. And then at the SDN layer, we're mapping and marking application traffic from all of our tenants into the appropriate class. And that's where, again, the capabilities of that VFP and the hardware offloads are very important, because if we're doing metering or pacing, you need to keep up with a very high packet service rate in order to have a nice sort of fluid flow of packets going into the network.
Do you have, just in continuation, do you have a centralized way of achieving that today? The configuration part?
The configuration, yes. So all of our configurations are centrally managed. Can we make a perfect emulation of a shared distributed token bucket? No. But that's, of course, the goal that we're trying to approximate.
Perfect. And I think we're unfortunately out of time here. Is that correct? So thank you very much to everybody on the panel. It was great. Thanks for the great questions.